Okay, so this time we want to find the integral from, oops, let's try that again, from 0 to 6 of g of x dx. Okay, well, if we're going to go from 0 to 6, look at what we've got. We've got the integral from 3 to 0, that's going backwards, because it starts at 3 and goes back to 0. And we've got the integral from 3 to 6. Well, seeing as this is broken up at 3, we can adapt what we've got here, and we can say we're going from 0 to 3 from g of x dx, and then complete it by going from 3 to 6. Okay, from 3 to 6 g of x dx, and I hope that makes sense to you. Overall, the path has to go from 0 to 6, but we're allowed to do that if we stop off at any intermediate step. So we can go from 0 to 3, and then go from 3 to 6, and we simply add the two answers. Okay, well, if we know that, what we can write is the integral from 3 to 0 of g of x dx is equal to 1. Well, one of the rules of limits of definite integration is that if we reverse the limits, so in other words, instead of going from 3 to 0, go from 0 to 3, what we do is we change the sign of the integral. So instead of the integral from 3 to 0 being equal to 1, the integral from 0 to 3 will be equal to -1. So we know that part, and then we know this part as well, because that's given directly in the question. So very quickly we can answer this question now. That's going to be the integral from 0 to 6 of g of x dx is going to be the integral from 0 to 3 of g of x dx plus the integral from 3 to 6 of g of x dx. Okay, and we just found out that this is equal to -1 plus the integral from 3 to 6. If we look back up here, that integral is equal to 4. So it's -1 plus 4, so the answer is 3. Okay, and I hope that made sense to you as well.